sine to the minus 1 is when we know the hypotenuse and the opposite. So we don't want to do it to death really, but I thought I'd show you these written out a bit more neatly once more. If we know the adjacent and hypotenuse, those two go with either the cos or inverse cos. So the cos of the angle is adjacent over hypotenuse, so the angle is cos to the minus 1 or inverse cos of adjacent over hypotenuse. And the same finally for tan. Tan of the angle is opposite over adjacent, so the angle is inverse tan of opposite over adjacent. So depending on what you want to know and what you know, there's always a way to figure out what you want to know using these functions, and hopefully you can go back over this video and have another look at it. And this is what we call a unit circle. It's a circle where the radius length is equal to 1, whether it's 1 meter, 1 mile, 1 volt, 1 anything. It can be any sort of unit, but we're representing the hypotenuse is equal to 1. And in our trigonometry, what you'll find is the hypotenuse, the longest side, is also the radius of this circle. So the radius of this circle, which is half of the diameter, is equal to the longest side of this triangle. It's also equal to the polar modulus. If you do polar complex numbers, it's the length, if you like, of the polar number, which is known as the polar magnitude. In electronics, the hypotenuse here is known as the amplitude or the peak voltage. And in a unit circle, all that means is the length of the hypotenuse here, the grey line, is equal to 1. And that makes things easier just to compare. It's easy to compare something to 1 or to compare it to 100%, because of course 1 is 100%. It's 100 out of 100 is 100%, and that's 1. So this just shows, this little animation shows that as the angle increases, it tells you what the angle is in this little bracket. As the angle increases here, the sine function, as in how big the opposite compared to the hypotenuse is, goes up. And the maximum that the sine can be is 1. And cos is similar, but the cos is equal to 100% or 1 when the angle is 0. And tan is just the ratio of how big the red one is to the blue one in terms of the triangle sides. So just to quickly say that another way, so hopefully it goes in a bit better. The sine of this angle here, whatever the angle is, it happens to be 39 there where I stopped it. The sine of 39 degrees is equal to how big the red length is compared to the grey hypotenuse, opposite over hypotenuse. The cos of 39 is how long the blue line is, the adjacent, compared to the hypotenuse. And the tan of 39 degrees is how long the red opposite is compared to the blue adjacent. So they all just change in relation to each other, and here all it really means is the length of the triangle sides changing as the angle changes. But when you see it as words, it's really sort of off-putting, but that's all it really means.